This lecture is going to be about classes and methods in R. So classes and methods are a system for doing object-oriented programming in R. And R was actually originally quite interesting and novel as a programming language because it was both structured as an interactive language, but also had a system for doing object orientation. So many other languages obviously support object-oriented programming, languages like C++, Java, Lisp, Python, and Perl. But generally speaking, these are not what one might consider interactive languages. And they're generally thought of as being languages where you write programs and you either run them through an interpreter or run them through a compiler to create an executable. R is both an interactive language, so you kind of type things at the command line and things happen right away, but it can also be used to write programs, and also it can be used. The object-oriented system can be used to create new types of data types. In R, much of the code for writing classes and methods was written by John Chambers himself, who was the creator of the original S language, if you remember from Lecture 1. And much of the kind of theory and design of the system is documented in the book Programming with Data, A Guide to the S Language. This is also sometimes referred to as the Green Book. So John Chambers actually is still working very heavily on developing the classes and methods system in R, and so new things are frequently appearing in the language as time goes on. The idea behind classes and methods and the ability to create new types of data in R it's a natural extension of Chambers' original idea of allowing someone to kind of cross from the user to the programmer. So remember, there was this spectrum that was kind of underlied the philosophy of the R language, or the S language, I should say, which is to allow people to kind of introduce themselves to the language as users, and then eventually, kind of as they use the language and they develop new and more complicated needs, they can become programmers and develop new types and program kind of new things into the R language. So the classes and methods system is really kind of for the programmer end of the spectrum, where people need to do new things that are not in the R language already. So the object-oriented programming in R is a little bit different than it is for most languages. So even if you're very familiar with other languages like C++ or Java or whatnot, you may want to pay attention a little bit to the details here, because it's not what you might expect necessarily as it is with other languages. So first thing that it's worth knowing is that there are two separate systems of object orientation in R, and they represent an evolution of the system across different versions of the language. So the first system is called S3 classes and methods. And this system was included with version 3 of the S language. It's a very informal system, and frankly a little kludgy. And this system is sometimes referred to, if you look on the web, it's sometimes referred to as old style classes and methods. The main limitation with this type of system here was that the new classes of data did not have a formal definition, and so therefore they were a little bit they could run into problems for more complicated situations. In version 4 of the S language, the S4 classes and methods system was introduced. This is a much more formal system and much more rigorous, and therefore a little bit less prone to kind of unexpected problems. It was included in S Plus version 6, which is the commercial version of the S language, and it was included in R version 1.4.0, which was around December of 2001. And these are sometimes referred to as new style classes and methods, or just S4 classes and methods. So for now, and probably for the foreseeable future, the S3 system and the S4 system are separate, and they will probably exist in parallel for quite some time, just because a lot of the older aspects of the language just depend on the S3 system. But you can mix the two together if necessary. So each system is fairly independent, and developers of new projects, so for example, people like you who may be interested in writing new things, are generally encouraged to use the S4 classes and method system because of their formality and rigor. And these are used, for example, very extensively in the Bioconductor project for those of you who are interested in kind of genomic or bioinformatic type analyses. But many developers still use the S3 classes and methods system because they're quick and dirty, and they're frankly much easier to implement than the S4 system. So I will talk a little bit about the S3 system here, but I'm going to talk more about the S4 classes, and the examples that I give will be for S4 classes and methods. and finally, the code for implementing S4 classes and methods system in R is all in the methods package. Now, the methods package will generally be loaded by default, so you don't have to do anything special to load it. But some systems may be customized and maybe don't load it by default, and so you can always load the methods package with the library function. So the way the object-oriented programming in R works is you have classes and methods, as you probably guessed by now. So a class is a description of a thing. So think of a data type, think of a new type of object that doesn't already have representation in the R language. So the class describes what the thing is, and the class can be defined using the setClass function in the methods package. So the second definition is an object. An object is just an instance of a class. So for example, a real number is a numeric. The class of a real number is numeric, right? So that's a kind of a continuous number between minus infinity and plus infinity, right? So the number 4.3 is an instance of that numeric class, and number 6.5 is another instance of that numeric class. So 4.3 and 6.5 are not the same thing. They are different objects, but they are all of the same class. So for new types of objects, you can create them using the function new. Now a method is a function that only operates on a certain class of objects, right? So so for example, there may be some functions that only make sense for example, numeric objects or integer objects or some new type of data class like a matrix, for example, or something like that. So a method, remember, is a function that only operates on a certain class of objects. Now, a generic function is any R function that dispatches methods. So typically the functions that you interact with are generic functions, and they're not the methods themselves. And a generic function usually encapsulates some sort of generic concept. For example, a plot, or the mean, or predict. So plot, mean, and predict, they can all have different behaviors depending on what you're plotting, what you're taking the mean of, and what you're trying to predict. And so those are generic functions. And the point of the generic function is that it doesn't actually do any computation. The generic function doesn't do anything. The only thing that a generic function does is it takes the data, figures out what class the data comes from, and then finds a method for that class and calls the method on that class of data. That's all the generic function does. So the generic function is kind of like a traffic cop. It sees data coming in and it matches it with the appropriate method. So finally, a method then is basically an implementation of a generic function for an object of a particular class. So those are the basic concepts of the class and method system in R. So if you're looking for documentation, there's a few places that you can take a look at. These help pages are the primary documentation for the system, so you might want to kind of refer to them regularly. So the first place is the help page for classes and for methods, and these are very long help pages, and they have extensive descriptions of how the system works. Following that, you can also look at the help page for set class, set method, and set generic. These have a lot of other details on how you can define a class and define a method. Now, the documentation, I'll admit, gets very technical, so you'll have to try your best for now. But it will kind of, as you continue to use the system, it will make more sense as you go along. And it's key to remember that most of the documentation in the methods package is designed for programmers. It's not designed for casual users, because casual users will probably not be wanting to define their own classes and methods for new data types. And so the general idea behind the documentation here is that you're a programmer and you're looking for these kinds of details. Okay, so just very basic examples of classes here. Every R object has a class, and you can determine what that class is with the class function. So for example, the number 1 by default is numeric, and we discussed this before. Even though 1 looks like an integer, by default, if you just say 1 without the capital L next to it, R will just assume it's a numeric or a real number. The logical true is a logical class. If you're simulating some random variables, those are numeric. NA by default will be logical, but you can also have character NA, numeric NA, and integer NA if you want. Those can be obtained through coercion. Finally, the character string foo is of class character, obviously. So data classes, those are the previous slide had the atomic classes, but of course the data classes can go way beyond that. So here I'm just fitting a simple linear model, a linear regression model with the LM function. And the object that is returned by LM has a class LM. So LM is both a function, but it's also the name of a class which represents a fitted linear regression model. And there will be elements, and then so that's like a new type of data. And you may want to do special things with that new type of data. For example, you might want to print the output in a special way. So you notice that when you print the object returned by LM, it has a very nice summary table of the regression coefficients and things like that. You may also want to call summary on it. So if you call summary on the output from LM, you get a regression table with standard errors and p-values and things like that. And so you can customize the output of a function by defining a class for the output and then kind of customizing the methods for that class. So a couple of notes about the differences between S4 and S3. S4 and S3 generic functions look different, but conceptually they're the same. They both play the same role, but when you look at the code, they will look a little bit different. When you write a program, when you write new classes or methods, you can write new methods for an existing generic, or you can create your own generic and associate methods with it. And if you encounter some data in R that you can't store an existing type of class, you can always create your own class and generics and methods to go with it. So here's a basic generic function. It's the mean function. So when I print out the code for mean, you'll see that it has a function prototype. So it's this function, and then x is this first argument, and then dot 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 is afterwards, right? So dot 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 remembers a variable number of arguments, and then the only bit of code in there is this function use method, and then it calls mean. So what use method does is it basically dispatches the method for a given data type. So x, the argument that's passed to mean, is going to have a certain class. The use method function will figure out what that class is, and it will dispatch the appropriate method. This stuff here with the bytecode and the environment, don't worry about that. It's not important right now. So the print function is another very important generic function. Lots of things need to be printed, but not everything needs to be printed in the exact same way. So it's important that different data types are printed in slightly different ways. And so so not everything kind of looks the same. So here you see print, the generic function for print takes a single argument x and then dot dot dot, which can be any number of arguments, and then it just calls use method. And so there, the use method will identify the class of x and then call the appropriate print method. So what kinds of methods are out there for a given generic function? So for the S3 system, you can call the methods function, and then you give it the name of the generic, and it will tell you what types of methods are out there. So there's a method for data frame, there's a method for date, there's a method for what's called default, and then a couple other classes here, diff time, POSIX CT, and POSIX LT. So you'll notice that the structure here is that the generic is the first part of the function name, and then it's followed by a dot, and then it's followed by the class of the object, which is either a data frame, a date, a diff time, etc. And so it's generic dot class. So you can also see what kinds of S4 generics and methods are out there too. So in S4, S4 has an equivalent function, a function that's equivalent to print, and it's called show. And so the show function, you can see here when you print out the body of the function, it prints out a little bit differently than an S3 generic function. So it says standard generic for show defined from the package method, so it tells you where the function is defined. You can see that the prototype here, it just takes a single argument called object, so no dot dot dot, and then it calls the function standard generic. So even though the names of the structure of the function looks a little bit different, and it's calling standard generic instead of use method, the basic idea is the same. The show function doesn't do anything. It identifies the class of the object, and then it dispatches the appropriate method. So both the show function and the print function, generally speaking, are not called explicitly very often because often objects will be auto-printed. But when you auto-print an object, it still calls the print method for that object. You just don't call it explicitly. So there are many different methods for the show generic function. So you can always call the function show methods on show, and it will tell you all of the classes for which the show generic function is. So these are all the methods for which show is defined. So, and you may not recognize any of these classes, but that's okay. So the first argument for any generic function is going to be an object of a particular class. There may be other arguments. For example, like the mean function has the na.rm argument, but those will be less important. So you want to be able to define the generic function as taking objects of a particular class. So, and the way the procedure works, and this is both for S3 and S4, is that the generic function checks the class of the object, and then it searches to see if there's an appropriate method that's just designed just for that class. If there is a method that's designed just for that class, then the generic function will call that method on the object, and then the method will execute, and then whatever happens, happens. If a method does not exist specifically for that class, then a search is done to see if there's what's called a default method. So this is a method that is called on anything for which no other method exists. If the default method exists, then the default method is called on that object, and then the method runs, and then what happens, happens. If a default method doesn't exist, then you'll get an error, because it doesn't know what to do in that case. So if you want to look at the code for an S3 or an S4 method, it's a little bit more complicated than just printing out the code for a function. So for a standard function, if you just print out the name of the function and hit enter, if you just type out the name of the function and hit enter, it will print out all the code that's in that function. But it doesn't quite work that way for classes for methods. So if you want to see how the mean function works for a particular type of data, you have to use a function to get the code for that method. So you can't just print out the code. So if you want to see the code for an S3 method, you can use the function getS3method, and it takes the form of the generic function as the first argument, the name of the generic function, and then as the first argument, and then the name of the class as the second argument. So for S4 methods, you can use the function getMethod, which it takes the generic function as the first argument and the signature, which we'll talk about later, as the second argument. So you'll know that if you're wondering how you know the difference between an S3 and an S4 method, you'll know by the way the generic function looks. If you print out the generic function and it has useMethod, that's an S3 function, and the methods will be S3 functions. If you see if you print out a generic and it calls the function standard generic like the show function did, then that's an S4 function. You want to look at S4 methods. So here's just a very simple example of how generics and methods work. So I'm going to simulate some random normal data, 100 variates, and I'm going to take the mean. So what happened here? So first, of course, I set the C to 2. Then I simulated the data and I stored it in an object called X. And now the X is an object of class numeric. Now, when you call the mean generic function, it will notice that it's of class numeric, but it will also notice that there's no specific method for numeric objects. However, there is a default method for the mean. So because there's no numeric method, it will call the default, and then it returns the mean of that vector. So what does the default method for mean look like? So here I'm calling getS3 method to get the default method for the mean. And I'm just looking at the first couple lines of this function, so you can see it takes an argument x, a trim argument, which allows you to take trimmed means if you're interested in that, and then an na.rm argument, which indicates whether you want to remove na values or not. So here are the first 6 lines, and then I'm looking at the last 6 lines over here. So ultimately, there's a lot of processing that gets done by the default method, but this .internal function indicates that most of the calculation for the actual mean occurs in C code, so you can't see the code there. So here's another example. I'm creating a data frame where the first column is a random normal vector, and the second column is an integer vector. So now I've got a data frame where the first column is numeric and the second column is integer. And then I'm going to call sapply on the data frame and the mean function. So what this does, now the mean is going to have a potentially different behavior on each column because each column is of a different class. However, actually, the first column is numeric and the second column is integer, but there's no numeric method for mean, and there's also no numeric method for no integer method for mean. And so in both cases it will call the default method, and you'll get the behavior that you kind of expect. So you might notice that there are some methods that you can just where you can just kind of that you can call directly. So the mean.default function is a function that you can just call if you wanted to, but you should never call methods directly. So you should in your code you should never have a call to the mean.default function. You should always use the generic function. So always call mean and let the method be dispatched automatically. This is generally that way if the methods change or if the name of the method change or maybe later on they implement a special numeric method just for the mean, then you'll always be kind of doing the right behavior in some sense because if things go out of date, you don't have to worry about it. So the idea is to use the abstraction of the generic function and only call the generic function and not to call the methods directly. Under the S4 system, it's not possible to call the underlying methods directly, so this is not a problem. It's only under the S3 system that for some methods you can call them directly. So here's another example of the S3 system. It's a plot. So the plot function is generic, and its behavior depends on the object that's being plotted. So here I'm generating some random normal data, and I'm just calling plot. And so what plot does by default. So x is a numeric vector, but there's no special numeric method for plot, and so you just call the default method for plot. And what it does is it plots the data against the index. So there's 100 elements in this x vector, so it's just going to plot x versus 1, 2, 3, 4, 5 up to 100. So that's all it does. And you see it looks like noise because that's what it is. So what if I do something a little bit different? So I'm going to create my random normal vector x, but now I'm going to convert it into a time series object using the as.ts function. So now I've converted x to a time series object, and I'm going to call the same function plot on x. And you can see that the plot is different. So it's different because now I have all the dots are kind of connected with lines, and so you get this line type time series plot instead of the circles that you saw in the previous plot. So that's basically how the methods will differ because there's a special TS method for plot, and so the plot function dispatched that method on this TS data type, and it created a slightly different plot. So, if you want to write new methods for new classes, you'll probably if you create a new class of data, you'll probably want to end up writing a method for the print method or the show method. The print or show generics, the summary generic, and maybe the plot generic. Because usually, if you're creating a new data type, you're going to want to be able to print it out in some useful way, and you're probably going to want to plot it in some useful way. And so there are two basic ways that you can extend the R system using classes and methods. We can write a method for a new class, but for an existing generic, so something like print or show, or you can write new generic functions and new methods for those generics. So here's just why would you want to create a new class, right? And the basic reason is you want to represent new types of data, right? So these are data that don't have a built-in way in R to kind of manipulate them, right? So you don't need to create a new class for numbers because there's a numeric class, there's an integer class, there's a complex class. So there's classes to store those kinds of data already. But what if you have gene expression data? What if you have spatial temporal data or hierarchical data or maybe sparse matrices? There's no built-in class for those types of data, and so you're going to have to define one for yourself. There may be just kind of new concepts or ideas or models that just haven't been thought of yet or haven't been implemented yet, such as a fitted point process model or a mixed effects model or a sparse matrix for mixed effects models. And you might want to define a class for these types of data so that you don't have to kind of expose lots of messy implementation details for people who may be using your software. And keep in mind that when I say that you want to have there's like a new concept or a new type of data, this doesn't mean that these are new to the world. It just means that they're new to R. So R doesn't have a built-in mechanism to deal with these kinds of things, so you have to write one for yourself. So A new class can be defined using the setClass function. So now I'm going to talk about S4 classes and methods, and the way you define a new class is with setClass. So the key difference between S4 and S3 is that in S3 there's no way to define a class. Objects don't have definitions. So for example, the numeric class, there's no definition for that. It just kind of implicitly exists. So it gets a little bit tricky because you don't exactly know what the definitions of these data types are. But under the S4 system, you have an explicit definition for every class of data, and they are defined using the setClass function. So at a minimum, you need to specify the name of the class. All right, so it has to have some sort of name that you give it. And you can also specify data elements for that class, and these are called slots. So these are these are elements of the object. So if you have an object of this new class, there may be elements in it that store data, and these data are stored in slots. You can define methods for the class using the setMethod function, and you can obtain information about an S4 class. You can get the class definition with the showClass function. So I'm going to go through a simple example here, which is creating a class for polygons. So polygons don't have a special data class in R. There's no way to explicitly represent them. Of course, you can think of different ways to represent them, maybe as a two-column matrix, maybe as a list, whatever it may be. But there's no explicit way to represent them in R. So I'm going to create an explicit way here. So, and this is, in case you're interested, this is taken from the GPC lib package, which is on CRAN if you want to take a look. So, and generally speaking, when you're creating new classes and methods, this is not something you do at the console, like typing in interactively. Usually, you're going to want to store this code in a separate file, and then source it into R later on, because there's going to be a lot of code here. You don't want to be having to write it over and over again. So here I'm calling the setClass function, and the first argument to setClass is the name of the class. So I'm just going to call it the polygon class, just because that's what it is. And then the second argument you see it says representation, and then in parentheses I'm going to define the slots. And so I have two slots in this polygon. One is called X, and the other is called Y. Both X and Y are numeric objects, or in this case they're going to be numeric vectors. And X is going to store the X coordinates of the vertices, and Y is going to store the Y coordinates of the vertices. And so that's basically it. It's very simple. It's a simple polygon class. It's definitely not the only way that you could have defined it. There are other ways you could have defined it, but that's the way I've decided to define it. So now, if you create an object of class polygon, you can access the slots, in this case X and Y, using the operator, the at operator. So the at operator is not one that we've used before, and it's specifically reserved for accessing slots in an S4 object. So I'm going to create a plot method for polygons, and it's going to be very simple. Basically, it's going to take the vertices of the polygon, it's going to connect them with lines. That's all it does. So, and I need to use the setMethod function to do this. So, for setMethod, you need to specify a minimum of three things. The first is the name of the generic function. In this case, that's going to be plot. The second is a signature, and the third is the function body. So, what's the signature? So a signature is just a character vector that indicates the classes of objects that are going to be accepted by this method. In this case, there's only one class of object that's going to be accepted by this method, and that's a polygon object. And so for the second argument to setMethod, I just say polygon, because that's the name of the class that this method accepts. So and then I give it the function body, and the one thing about the function body is that the prototype here, which specifies the arguments, has to match exactly the function definition for plot. So if you recall from before, the plot function takes two arguments, x and y, and then it has ... And so your method here also has to have x and y in it. You can add other arguments beyond x and y, but you can't change the x and y arguments, because that's part of the original generic function. So now you can see in my function body, the first thing I do is I call plot again, right? So I'm calling plot within the plot function, and that's fine, because the reason is when I call plot again, I'm calling it on the slots for this object x, and in this case the x and y slots, which denote the vertices. All right, and so because now the x and y slots in this object, they are numeric objects, and so when I call plot again on them, there's no numeric method, so it's just going to use the default method for plot, and it's just going to plot the vertices on the window. However, I'm specifying type equals n, so it's not actually going to plot anything. However, it's going to set up the plot window and so that I can later add things. So now what do is I'm taking the vertices in the second and third line here, I'm taking the vertices of the polygon, and I'm creating a new vector which just tacks on the first vertex onto the end. So I'm creating a closed loop. And then after I've done that, I call the lines function to draw lines in between all the vertices. So notice that in this plot method here, I accessed the slots using the @ operator. So even though I called plot within the plot method, it doesn't create an infinite loop because I'm calling within this method, I'm calling plot on a different type of data. So when I run this through R, I create the new class with setClass, and setClass, if everything works okay, will not return anything useful. So you won't get any readout or any printout or any information. It will just run. And then when I call the set method function, if there's no error, what it will print out, it will return the name of the generic function that you created the method for. So you're not going to get any useful messages or output from either of these methods. What setClass and setMethod do is they have a side effect, which is that they kind of register the class and they register the method with the system. So just to note, if you quit R after calling setClass and setMethod, everything is forgotten. So when you start up R again and later on, you're going to have to redefine this class. You have to redefine this method. So after you call setMethod for the new plot method for polygon objects, that method gets added to the list as a global list of methods for plot. And so if you call show methods on plot, you'll see that there are two plot methods defined. The first is for any, and the second is for polygon. So the second one is the one that we just defined. But the one for any is the default methods, so the default method takes any type of object. It doesn't care. So if I were to call plot on some other type of data, it would use the any method or the default method. However, if I called plot on on a polygon object, it would call my method. So here, very quickly, I'm creating a new polygon with the new function. So for the new function, I give it the name of the class, which is polygon, and then I'm going to fill in the slots. So for x, I say 1, 2, 3, 4. Those are the x coordinates. And for y, I say 1, 2, 3, 1. Those are the y coordinates. So that's my polygon. And I'm going to save it to an object called p. So when I call plot p, the generic function plot will check the class of my object. In this case, the class is called polygon. It will look for a method that's defined for that. Indeed, I have already defined one, so it calls my method. And you can see that when I call plot, what it does is it connects all the dots and draws my little polygon right here, as expected. So that's the basic idea in terms of defining a class and defining a method for that class. And you can obviously extend this to much more complicated types of data. So there's a number of places where you can go from here. I put a few exercises on the website that you can try to run through and try to define your own classes and methods. And the best way to learn this kind of stuff is to look at examples. So hopefully you can try to work through a few right now. There are many examples on CRAN. These are packages that use S4 classes and methods, so you can check those out. The Bioconductor project has a lot of packages that make extensive use of S4 classes and methods. So even if you're not interested in bioinformatics or genomics or anything like that, it's still a useful place to go to if you want to learn about programming in this style. There are a number of packages on CRAN. I'm just going to name a few here: the SparseM, the GPClib package, which I've written, the FlexMix, ITS, LME4, OrientLib, PixMac. These all use S4 classes and methods. Also, the Stats4 package, which comes with R, so you don't have to install it, has a lot of classes and methods for doing maximum likelihood analysis. So this is a statistical concept which you may or may not have learned, but if you're familiar with maximum likelihood analysis, you may be interested in just looking at the code for the stats4 package because it uses a lot of these S4 classes and methods. So that's a very, very quick introduction to the S3 and the S4 class and method system. There's obviously a lot more to talk about, but I think my goal was to try to get you started with a little bit so that you could try to define your own data types and methods. You may go a very long time before you feel the need to use this system because a lot of the built-in stuff for R is quite useful, and there are many, many packages now that will kind of deal with all kinds of interesting data. So you may not feel a strong need to define a new class or a new method, and that's fine. However, eventually you may come across a situation where you need to define something new, and this is the way to do it.